Hello, guys. Let us have a look at the buddies of Indian summer monsoon. Means the factors that affect the intensity of the Indian summer monsoon, the wind velocity, and the rainfall associated with it. We all know that the Indian monsoon refers to the seasonal reversal of winds. We have studied about two types of monsoon, the summer monsoon and the winter monsoon. Summer monsoon normally is from June to September with a wind direction of southwest, means the winds blow from southwest to northeast. While the winter monsoon, which is from November to March, the wind direction is northeast. So it comes from northeast and go towards the southwest. So we'll say southwesterly winds are the summer monsoon winds and northeasterly winds are the winter monsoon winds. We have also studied that the Indian summer monsoon is stronger than the winter monsoon and it accounts for 80% of the rainfall in India. India being a country which is heavily dependent on agriculture, this monsoonal rainfall is very, very important. Can see here in this plot that the months of June, July, August, and September they account for the maximum amount of rainfall that is there in India. The main factors that impact the Indian Ocean are temperature, pressure, physiography, and ocean atmosphere interactions. So we all understand this fact that temperature and pressure they both are interrelated. So if the temperature is high, it will lead to low pressure, and when the temperatures are low, it will lead to high pressure. And we know that the winds they blow from high pressure to low pressure. We have also seen the impact of orographic features. Orographic features like Himalayas, Western Ghats, and Tibetan Plateau on the monsoon, its intensity, and the rainfall. So we can say that these factors, temperature, pressure, and physiography, they are very important. The fourth factor, the ocean atmospheric interactions, they are also extremely important. Always remember that whenever we talk about some uh, weather or climatic phenomena, it can never be completely dependent on atmosphere or completely dependent on ocean. So the climatic phenomena they are always controlled by these ocean atmospheric interactions, and we'll see how it impacts the Indian summer monsoon. The first most important buddy or the friend of the uh, Indian summer monsoon is the Masquerade High. So let us see what is Masquerade High. In the Indian Ocean, near the Mo- African coast, there are islands in near Mauritius, over somewhere over here. These are the Mascarene Islands. Mascarene Islands. So what happens over here is that during the summer months, which is June, July, August of the northern hemisphere, we all know that these are the winter months for southern hemisphere. So near the Mascarene Islands, there is an unusually low temperature, and this low temperature of Mascarene Island is because of the impact of the Antarctica and associated features. Since the temperature over here, it has low temperature, so we all understand that the pressure in this zone will be high. So this high pressure zone, it is called as Mascarene high. Now we all understand this that when the pressure will be high, the winds will start blowing from this high pressure towards the low pressure. And if you see this diagram carefully, the temperature of the Indian landmass near Rajasthan and Gujarat and central India, this is very high temperature. High temperature means the pressure over here shall be low. So what will happen is that this low pressure zone will attract these winds from over the Arabian Sea. But the source of these southwesterly winds, we say that this is the southwest monsoon winds, but this source of this wind is this Masquerade High, which is considered to be a powerhouse of these winds, and it is quite far from the Indian subcontinent. But due to the extremely high pressure over here, these winds which come out from this high pressure zone, they cross the equator and then they merge with these winds and they enhance the southwest monsoon. So this high pressure region, which is located near the Mascarene Islands, which is termed as Mascarene High, let me show you how these winds look like. So because of the Mascarene High, you can see the direction of these winds. So this zone over here, see, this is the high pressure zone, and you can see the direction of these winds from this area. The winds are dissipating out. So here this is an anticyclonic uh, movement, and you can see the direction of these winds. They are coming towards the African coast. They hit the African coast, then they cross the equator, and then they merge with these winds from over the Arabian Sea. They reach the Indian subcontinent. So we can say that the Mascarene High, or the high pressure zone formed near the Mascarene Islands, is one of the best friends or best buddies of the Indian summer monsoon. So let me put it here for you. It is one of the best buddies or best friends because of its ability to provide high velocity wind to the summer monsoon. So always remember that these winds from the Mascarene High, they help in the onset of the summer monsoon. If this Mascarene High, it gets delayed in forming, then it may delay the onset of the Indian monsoon. So we have to say here that the formation of this high pressure zone near the Mascarene Islands and in the vicinity of Australia, it becomes a powerhouse of these winds, and therefore it strengthens the Indian monsoon and makes sure that Indian monsoon hits the coast on time. It doesn't get delayed. Okay. So first is the Mascarene High. Second is, we all understand this and it's very common, that the Coriolis effect. We all know about the Coriolis force, and in this on this right hand side video or this animation, you can see that as these winds they cross the equator, they turn right in the northern hemisphere. So this is the Ferrell's law. So he stated that due to the Coriolis effect, the winds they deflect towards the right of their path in the northern hemisphere, while they deflect left of their path in the southern hemisphere. So Coriolis force is a very important phenomenon. Now, as I had already told you that the summer monsoon means the summer months in India, they are June, July, June to, let us say, September, the summer monsoon season. This is the summer month. But at the same time, these summer months are winter months for the southern hemisphere. So the Australian landmass, it cools down, which enables it to get extremely high pressure. Once this pressure becomes high, the winds start dissipating from over here. This is the zone of Mascarene High. Mascarene High. So these winds which come from over here, then they get deflected. They get deflected towards the northern hemisphere. And I had already also told you that the winds coming from the Australian landmass, they are south easterly winds, but as they cross the equator their direction changes to southwesterly, which gives the named southwest monsoon to the summer monsoon. So it becomes very evident that if you focus in this zone over here, it becomes very evident that the Coriolis effect is one of the major factors that impacts the strength of the Indian monsoon. This is because of this Coriolis impact, the Indian monsoon breaks down into its two branches, the summer monsoon, and then, of course, the physiography of Indian landmass. So, the wind movement in all the conditions has to be controlled by the Coriolis force, and thus Coriolis force becomes also one of the most important bodies of the Indian summer monsoon. So, an important body, we can write it over here. Imagine if the Coriolis effect wasn't there, then these winds would not have been able to cross the equator and then turn right towards the Indian subcontinent and then carry on with the proceedings of the summer monsoon. The next one is the Indian summer. Indian summer may also be referred to as the Indian monsoon's guide. Indian monsoon guide. Why I am saying this? In the beginning of this lecture, I told you that temperature and pressure, they are interrelated. So the location of the Indian subcontinent is such that when it comes to the summer season, now we all understand that the summer season, which is in the month of June, and 21st June is the summer solstice. So during this time, the sun is at its highest point in the northern hemisphere, and that particular time, the heating of the Indian land mass, it increases the temperature so much that the entire Indian subcontinent develops a low pressure zone. So during the summer, the states of Rajasthan, Gujarat, and then Pakistan, all these areas, they heat up extensively. At the same time, the temperature of Arabian Sea as well as Bay of Bengal also increases. But then again, you have to keep in mind over here the specific heat capacity. So we all know that the specific heat capacity of water is extremely high, due to which it warms slowly than the Indian landmass. Therefore, there becomes a gradient between the air pressure over the sea and that over India, especially the Rajasthan region. Now, what happens over here is in this second map, you can see that the pressure over Rajasthan and Gujarat region is quite low or extremely low, we can say. The pressure over here is very, very low. As a result of this low pressure zone over here and high pressure zone over the Arabian Sea, these winds, they get attracted towards Rajasthan. Now, interestingly, Rajasthan lacks uh, uh, any major orographic feature. No such mountains, high mountains in Rajasthan. So therefore, these moisture laden winds, they are able to cross Rajasthan and then they enter the central and northern Indian portion. So these winds, they do hit the Himalayan mountain belt, where they are forced to rise up and then they cause rainfall in the Indo-Gangetic Plain region. So the Indian summer is extremely important. It provides the generating heat for the development of pressure gradient, and then these winds are attracted towards the Indian subcontinent. Next important feature which everybody is so interested to talk about is the El Nino. El Nino is also referred to as Christ child, a name given by the fishermen of Peru and Chile region. And then it normally comes in the month of December near the Christmas time. So, what is El Nino? I'm not going to get into much detail of El Nino, but yes, I will explain to you the phenomenon. Let us imagine that we have a glass of warm milk which is kept in a steel plate. So, if we keep that milk in that glass and put that warm glass on the steel plate, only that side of the steel plate will get warmer where that glass is kept. Okay, so this condition, so let us consider this entire plate as the Pacific Ocean basin, because El Nino and La Nina, they are typical of the Pacific Ocean. So this plate, let us consider this as Pacific Ocean basin, and this warm milk over here, it is the Western Pacific warm pool. Western Pacific warm pool is a pool of warm water which is formed on the western side of the Pacific Ocean near the Indonesian islands. This warm pool is formed because of the continuous flow of north and south equatorial currents under the impact of the trade winds. So, what happens is that, if let me draw a schematic diagram, if this region is the western pacific and this is the eastern pacific, now these, and let us say that this is the equator, 0 degree, these are the trade winds. The arrow represents the trades or the trade winds. Now, what will happen is that these trade winds, they will bring the warm water of the equatorial Pacific region with the help of north equatorial current and south equatorial current, and it will pile up over here in the Western Pacific region. This is called as Western Pacific Warm Pool. So this glass of milk represents the Western Pacific Warm Pool. So imagine that if this Western Pacific Warm Pool is restricted on the western side of the ocean, or it is on only this side of this plate, so only one side of the plate will become warm, the other side will remain cool. But let us say that this milk is spilled in the plate, this milk is put in the plate. So what will happen now? This milk, the warm milk, it will make the entire plate warmer, makes the whole plate warm. As a result, the entire Pacific Ocean basin becomes warmer. So imagine that there is some mechanism that this Western Pacific warm pool water, it starts to flow back towards Eastern Pacific. Let us, I'm making this by brown color. Let us say that it starts flowing towards Eastern Pacific. So what will happen? This whole area will now become warm. So once this happens, why does this happen? It's very simple. Because when Western Pacific warm pool was being formed, it was because of the strong trade winds. But once the trade winds become weak, this north and south equatorial currents will also become weak. And therefore, now this Western Pacific warm pool will not get continuous supply, and the water will start flowing towards the Eastern Pacific. So I hope you understood this idea. Now imagine that when the Western Pacific warm pool is good, it is strong. So what will happen? So on the western side of the, okay, let me show you in this diagram. If the western, let us say that these are the trade winds. We have these stronger trade winds. Okay. So these are the trade winds. The trade winds, they will bring the warm Pacific water towards the western Pacific area, and this will lead to the formation of a large warm pool which is restricted to the Pacific Ocean. On the western side of the Pacific Ocean, this pool is known as Western Pacific Warm Pool, WPWP. Now, you should understand this that once the Western Pacific warm pool is restricted on the western side of the Pacific Ocean, then the temperature of the Eastern Pacific will be lower than the Western Pacific. So, temperature of Eastern Pacific will be lower than temperature of Western Pacific. As a result, the pressure of Eastern Pacific will be higher than the pressure of Western Pacific. I hope you understood this. So we can write over here that this is the high pressure zone and over here it is the low pressure zone. So as is the convention, the winds they will start blowing from high pressure towards the lower pressure zone. And over here, over the area where we have this low pressure zone in the Western Pacific, these warm water they start to get evaporated. So there will be lot of evaporation. Let me draw it with a darker color. Lot of evaporation will happen over here. Just let me make this change this background, please. Give me a second, guys. Okay. So we had seen that the sorry we had seen that the temperature of Eastern Pacific was less than temperature of Western Pacific. As a result, pressure of Eastern Pacific is more than pressure of Western Pacific. So what will happen, as I was telling you, that the winds start to blow from the Eastern Pacific towards Western Pacific. At the same time, over the Western Pacific, there is lot of evaporation because of warm water pool over here. So these winds they start to rise, and at the same time, these winds, these moisture laden winds, they start doing rainfall over the Western Pacific region. Extensive rainfall happens over Western Pacific region. Heavy rainfall. And so much so that the Indonesian archipelago and islands they suffer floods. These winds then they reach the tropopause, go back towards the Eastern Pacific and sink over the Eastern Pacific. So while sinking, these winds are cold and dry with almost no potential for the rainfall. Therefore, during this time, which is called as La Nina, the uh, Indonesian area, the Western Pacific region, it suffers heavy rainfall, while the Eastern Pacific region almost no rainfall. But every so I hope you understood this thing. Let me add one more slide here and then this picture again so that I can explain to you the Yeah, sorry. Yeah, sorry guys about this glitch. So now we are going to understand the El Nino concept. So the previous concept which I discussed was La Nina. Now El Nino. So what will happen now is in the previous case we saw that the pressure difference on the eastern and western side of the Pacific Ocean causes a wind circulation to develop over the Pacific Ocean. This wind circulation, which is typical of the Pacific Ocean, it is called as Walker circulation. Walker circulation. So during La Nina, what happens is that a Walker circulation is established. Lot of rainfall on the western Pacific side because of the western Pacific warm pool. The eastern Pacific, it suffers droughts. It has no rainfall because of the cold and uh, dry air which sinks over there. I am not discussing the oceanographic phenomena associated with El Nino and La Nina because I just need to tell its impact. So La Nina, during La Nina, this warm pool, the Western Pacific warm pool, it has lot of warm water over there, which leaks to the Indian Ocean, South Indian Ocean. This phenomena is called as Indonesian through flow. There is a video of mine on the ITF, Indonesian through flow. So you can go through that video if you wish to understand the phenomena. So now what happens is that during this time, when the Western Pacific warm pool is well developed, the Southeast Indian Ocean, it gets warm water and the temperature over here is higher. High temperature means low pressure. So what will happen over here? That this low pressure zone which creates plus evaporation in the southeast Indian Ocean, these winds from Australia, they will bring in this moisture over the Indian subcontinent and it is good for the Indian summer monsoon. So we can say that La Nina is good for, it helps the Indian summer monsoon. But the El Nino condition, during El Nino condition, why does El Nino come? It is seen that every 3 to 5 years, the trade winds they become weak. It is an observation that weak trade winds. So what happens is as the trade winds they become weak, the north and south equatorial currents will also become weak because the water which is being continuously brought in is now not being brought in over here. So the north equatorial current and south equatorial current they become weaker or they diminish. They are not allowed to bring continuous supply of water towards the Western Pacific. So what happens over here is that now this Western Pacific warm pool water it starts to flow back towards the Eastern Pacific Ocean. Now this is the same thing like we had spilled that warm milk in the plate. So now this Western Pacific warm pool water flows towards Eastern Pacific. In this process, it makes the Central Pacific region warmer. Okay, because now this warm water has come in this side, so the Central Pacific region it becomes warm. Now what this will do? This will cause the low pressure zone over here. At the same time, evaporation will also start to happen because the temperature is high. So here evaporation happens. So evaporation occurs in the Central Pacific. And then we get two cells now operating. So as this air rises, which is moisture laden, it causes rainfall in the Central Pacific over here. And then one branch of this goes towards Western Pacific, then sinks and then comes back, while the other one goes towards Eastern Pacific, sinks and comes back. So we see that the Walker cell gets disrupted. Walker cell is broken or it is disrupted. As a result, the warm pool which was there previously on the western side of the Pacific Ocean, now it is diminished, it is weak. Then this will also cause reduced Indonesian through flow, reduced ITF. Means now the temperature of Southeast Indian Ocean will not be high, and the moisture content of the winds, it will be very very low. So under such circumstances, the indian monsoon Indian summer monsoon rainfall is reduced reduced. So if we see this diagram, uh, 2014 to 16 was one of the El Nino years. So see the first map. In this, if you see the sea surface temperature, now the water from the Western Pacific region is flowing towards the Eastern Pacific. See, the highest temperature is marked by this pink color. So we can see that this water is slowly flowing toward the Eastern Pacific. And see here in the second picture, now this has substantially warmed the Central Pacific region. So this phenomena will occur in the Central Pacific region where the Walker cell gets disrupted, and therefore the region of the Southeast Indian Ocean will not receive the requisite amount of heat which it was receiving in the case of La Nina. So therefore it has to reduce the moisture content of the wind, and of course the Indian summer monsoon will be reduced. If you see this relationship between the rainfall and El Nino, we can see by this plot over here that the major droughts, the severest drought years, they have coincided with the El Nino. So right from 1980 to 2014, we can see over here that the normal rainfall is associated with the La Nina or normal conditions, but the severe drought conditions, they have been associated with the El Nino condition. So later we can see here that these circles, they represent El Nino years. So see this red color, it is drought El Nino. This is again with El Nino. Then this is drought El Nino, drought El Nino. Now you can say that there are of course some of the El Nino years where there was deficient rainfall. So it happens. It's uh, there are a few examples where the El Nino had no impact on monsoon. So this is very, very kind of ambiguous phenomena, and therefore El Nino can be called as an undependable, undependable friend or buddy of Indian summer monsoon. Because sometimes it may disrupt the Indian monsoon to the condition that there is severe drought. Sometimes there is only some deficiency in the rainfall, and sometimes there is no effect at all. That is why the climatic phenomena, they are very chaotic. You can never have a linear relationship between the atmospheric phenomena and say that in a particular year there will be rainfall, or in other year there won't be any rainfall. It's not like that. And this is the reason that sometimes people several people have predicted El Nino, and said that this year the rainfall will be very less, but the rainfall were more than normal, and as vice versa. So several times El Nino has caused the predictable models to fail, and thus we can call El Nino as an undependable buddy of the Indian summer monsoon. A more recent phenomena which has been discovered in the year 1999 was the Indian Ocean Dipole. Indian Ocean Dipole is a phenomena in which the eastern and western sides of the Indian Ocean, they warm and cool simultaneously or alternatively. So uh, that is called as a dipole mode. So for example, in 2019, the Indian Ocean dipole showed a positive phase, positive Indian Ocean dipole. So what does positive, negative, and neutral mean? The positive phase is the positive phase is the one in which the western side of the Indian Ocean warms considerably. So, in the western side of the Indian Ocean, the sea surface temperatures are warmer than the eastern side. So, once the sea surface temperature on the western side will be warm, means it will cause a lot of evaporation, lot of moisture content will be there, and it will boost the monsoon winds. While once there is a negative phase, it becomes exactly reverse. In the negative phase, the uh, eastern side of the Indian Ocean becomes warmer than the western side. So during the positive phase, the eastern coast of Africa receives good amount of rainfall. While during the negative phase, the eastern side of Africa it suffers severe droughts. While during the positive phase, Australia suffers droughts. While during the negative phase, the Australian landmass gets good amount of rainfall. So we can understand over here that positive phase of the Indian Ocean dipole, it is good for or it makes the Indian summer monsoon stronger. So positive phase is good for summer monsoon. It is a stronger summer monsoon. While negative phase is just the reverse. So if I try to explain over here in this diagram, let me again make it in black color. And one more slide I'll add to show for the negative phase. All right. So let us first look at the positive phase of the Indian Ocean dipole. So in the positive phase, the temperature of Western Indian Ocean temperature is warmer than temperature of Eastern Indian Ocean. Why does this happen? Once these easterly winds develop, then they will bring the warmer waters near the coast of Africa. And this warm water which is piling up over here, these warm waters, they lead to the evaporation, extensive evaporation over here in this zone. So the winds also rise and evaporation happens. So lot of rainfall over the African coast, and then these winds they sink over Australian area. These are cold and dry. So this circulation cell which develops over here, it is called as the positive phase. When the western side of the Indian Ocean becomes warmer, at the same time it also makes the Indian summer monsoon stronger because the evaporation that is happening up over here it gives a boost to the Indian summer monsoon. So during the positive phase of the Indian Ocean dipole, the summer monsoon witnesses high rainfall. The positive phase is also important sometimes to the extent that the positive phase of Indian Ocean dipole, if it has occurred during El Nino year, it has positive phase of Indian Ocean Indian Ocean dipole during El Nino years helps to maintain the southwest monsoon rainfall. As previously we just saw that the El Nino may cause the disruption of the summer monsoon and it may lead to the severe droughts. But if that El Nino year is coinciding with the positive Indian Ocean dipole phase, then it will help to counter the attack of the El Nino, and the Indian summer monsoon rainfall may not suffer much. During the negative phase, now westerly winds they develop. Westerly winds they develop, and they bring the warmer waters of the Indian Ocean towards the sorry warmer waters of the Indian Ocean towards the Australian region. So this warm water, it leads to evaporation, thereby causing the formation of clouds and rainfall over the Australian landmass. So, rainfall over the Australian landmass. At the same time, the African landmass, it suffers droughts. And then this circulation develops, dry air sinks over here. So during the negative phase, we see a reduction or weakening of the weakening of Indian summer monsoon rainfall. This is because now here on the coast of Africa, the evaporation of the warm of the water is reduced because of the cooler temperatures, relatively cooler temperatures. So the negative phase is prob it reduces the strength of the Indian monsoon winds and the rainfall, while the positive phase, it is good for the Indian monsoon and it enhances the rainfall. So these are the uh, few factors which control the Indian monsoon, in that case, we may say that these are some of the friends or buddies of the Indian summer monsoon. Now, do not expect them to be 100% uh, perfect factors. As I had given you the example of El Nino, that in some cases El Nino may not impact Indian monsoon at all. In some cases, it is only deficiency, and in other cases, it leads to severe droughts. Similarly, if Indian Ocean dipole positive phase coincides with the severe El Nino years, it may help to maintain the balance between the rainfall of the summer monsoon. So all these factors, they are still being debated and being researched on, and hopefully we will get more data in the near future, and it will be more easy to predict the monsoon. Of course, the prediction done by the Indian Meteorological Department, it is now almost near precise. But for a country like India, which has very dynamic meteorological phenomena and very chaotic weather system, it is not easy always to exactly pinpoint that today there will be rainfall or today the monsoons are going to hit. But yes, these days, due to the enhanced and improved quality of our tracking systems and our predictions, Indian Meteorological Department is doing a wonderful job, and we get very precise, nearly precise uh, announcements and forecast. Okay, so I hope you were able to understand the factors that impact the Indian summer monsoon, and a lot of questions on this may be framed for the CSIR net examination. So you all should try to build this concept, should try to read about it, and then if you have any doubts, you're always welcome to post me those questions. Okay, so I hope you will enjoy this video. Thanks a lot.